So this presentation is on eutectic and eutectoid reactions, and this slide was made by me, written by me, and presented by me, Jake Walsh. So our agenda for today, I'm going to do an introduction on the eutectic and eutectoid reactions, and I'm going to go over some background information. Then I'm going to show some visual examples because in this case, visual examples are very key to learning this topic. Then we're going to do a summary and conclusion. So, introduction, a eutectic and eutectoid reaction. There are different types of reactions as the names imply. Eutectic reactions occur when two melted solids hit a point called the eutectic point, where the lowest temperature at which a solid solute, solid solvent, and liquid mixture exist in the same phase. Eutectoid states are when two or more crystal phases are formed simultaneously into a solid solution. But really much so, an easier way to think about this is eutectic is solid plus solid equals liquid, and eutectoid is solid plus solid equals another solid. And that's just a much more simplified and easier way to break things down. So some background information about this. The term eutectic was coined in 1884 by a British physicist and at the same time a chemist, Frederick Guthrie, who lived from 1833 to 1886. The word originates from the Greek word eu, which means well, and texas, which means melting. So that really helps us figure out the eutectic point and what the eutectic point really means. It's a point where it all melds together, essentially. So here are some visual examples, and this is very important for this topic because you can specifically see them on a graph, and in fact, it's made to be observed on a graph. As you can see, eutectic points and eutectoid points, they are certain points on a graph. So without visual examples, you wouldn't really be able to see what they would look like. So on the left, you see a eutectic point. You see that alpha plus beta is on the bottom, and on the top is liquid. L stands for liquid, and that point where the alpha plus beta meet the liquid, that little dot where it's labeled eutectic point, that's the eutectic point. That's where the two solids, alpha and beta, are kind of like at a critical point. It's kind of like a critical point. Now on the right side, eutectoid, you see the eutectoid. There's a lot going on in the graph, but eutectoid is right below the word austenite, right below gamma. And you can see that austenite is a solid. Let's see, alpha in this case is also solid, and same with Fe3 carbon. That's also solid. So again, eutectic is solid plus solid equals liquid, and eutectoid is solid plus solid equals solid. And we can see that in the graphs where alpha plus beta meets with liquid, and alpha plus Fe3 carbon meets with austenite, or otherwise shown as gamma on this chart. So, in summary, eutectic and eutectoid reactions are used in material science to create alloys that have specific properties that are beneficial. We can use eutectoid reactions to create things like ferrite and cementite, and we can use eutectic alloys for things like soldering, as they have a single temperature range to become liquid and solid uniformly, so they basically are good things to solder with. Thank you. My name is Jake Walsh. Thank you for watching my presentation on eutectic and eutectoid reactions.